Hello, folks, and good whatever to you. Anyways, today we're going to be talking about stem anatomy, okay? So, real quick, let's go over to our PowerPoint. So, stems take hairy stuff. They also hold stuff up. That's about it. Anyways, but they have to be kind of complex to do this stuff. So, water and minerals travel from the roots up to the leaves via the xylem. Sugars produced in the leaves travel down the stem via the phloem. So, sugars are flowing on down. So, think of maple sap. So, phloem flowing on down. Okay. Sap. So, phloem sap, that's carrying sugars. So that's what you want to hit when you're tapping a tree for maple syrup. And xylem sap is fluid carrying water and minerals, so junk to us in most instances. So there are two stems. They're either herbaceous or woody. Pretty straightforward. Most of you know how to identify a woody stem by sight, or if you put it in your hand and try and snap it, you can tell herbaceous versus woody. Okay. But woody stems are going to be in your longer lived eudicots that are going to build up tissue year after year. So let's take a look at an herbaceous eudicot stem. So real quick, that'll be, here's our line drawing of this. Most of this is not going to be terribly important for the practical. We're not going to ask you about the medullary ray or the collenchyma. We might ask you about the sclerenchyma. We will ask you about the xylem and the phloem. Yeah, probably not going to ask you about the cortex or the collenchyma or the epidermis even in this slide. Definitely not going to ask you about companion cells or the medullary ray, okay? So don't worry about some of these very obscure things. Worry about the stuff that is labeled in these images like this. So worry about your xylem, your cambium, your phloem, your sclerenchyma. So your xylem, true to like I told you earlier, is always going to be the largest pores in these vascular bundles. Phloem nearby, and cambium is this little tissue that's a little bit off color in between the xylem and phloem. And cambium turns into xylem and phloem, and that's why it's in between the two. Sclerenchyma is this very dense pack of fibers that is there to protect these vascular bundles from damage. And so that's why it's going to be on the outside of these vascular bundles. Let's go back. See sclerenchyma always on the outside. So let's look at our real life example of this. So not the prettiest one, but here we go. We have another one. Yeah. Not the prettiest. It's okay though. They show us what we need to see. So when we're looking at this, what you'll need to be able to identify, go up to 400x total magnification. And I'm gonna undo that flip. All right. So when we look at this, we know that this is the xylem. We know that the phloem's going to be over here buddied up against the sclerenchyma, and the cambium is in between the two. And this is our sclerenchyma protecting it because our epidermis is over here. If we zoom out again, we would know that this is going to be a eudicot because the arrangement of those vascular bundles in a ring. Let's go back to our PowerPoint real quick. So in a eudicot stem, those vascular bundles are arranged in a ring near the outside of the stem. This is kind of funny because in the roots, it's exactly opposite. Monocots have vascular bundles in a ring. So next we're going to talk about a monocot in cross section. So let's take a look at that real soon. There is our line drawing of that one. So again, a lot of this is stuff that we aren't going to ask you about, like companion cells. Not going to ask you about them. Okay, whatever the hell that is. Okay, not going to ask you about that one. All right, worry about your xylem, worry about your phloem, know where your sclerenchyma is. And if you're looking at this, know that you're looking at a monocot because these vascular bundles are scattered throughout the stem. This is a monocot stem. Okay, so let's go ahead and look at our real life example of, wait, hit the brakes real quick. Let's go back. We actually have pictures of that. So here we have our vascular bundles, epidermis on the outside. Let's get a closer look. Here we have more little terrified faces. Sclerenchyma is on the outside. Remember, it's protective. Xylem is these large pores. So big hollow eyes. The phloem, in this case, is going to be on the forehead of our little faces. That one looks happy. All right. So let's go over to our real life example. So this is at 40x total magnification. You see vascular bundles scattered throughout this stem, all over the place, way off in the middle, over by the edges, everywhere. Okay, and they look pretty good. I like them a lot. But I'm spoiled for choice, so I'm going to come over here and take some pictures of these ones instead. So let's take a good close gander at some of these. Sure enough, look at them all. Oh man. Plant anatomy is kind of fun. Just because you have some really cool, very visually appealing slides like this. Oh, look at all the little terrified faces. Yep, you even got a little nose. That crazy term that I'm not asking anyone to remember, that would be the mouth there. But what we're, and so I guess that could be a little bit deceiving. Do not mistake that for your xylem. So the xylem is the eyes of our little horrified faces here. The phloem is the little empty heads, just like ones I'm trying to fill all the time. Okay. So back to our PowerPoint. So sclerenchyma on the outside, little hollow eyes are the xylem, phloems, the little hollow head. We wanted to go back real quick. The little mouth would be the codoxylem, lacuna, if you really wanted that one. But I'm not going to ask you about it. So here is a woody stem. It has growth rings, concentric rings of xylem that show the amount of growth during the growing season. Spring wood, that's what we're going to call it here, is the light rings, and summer wood is the dark rings, where there is less water, and so the growth has to slow down. So on a woody stem, you have pith in the center, which stores starch, xylem, cambium, which has your secondary growth where it is growing outward, becoming wider, and then bark, which is all tissues from the cambium to the outside layer. And there is where you'll have phloem. So we're looking at our little wood here. We have our growth rings. These annual rings are made up of xylem. Way down the middle is pith. And then way out here, you might see these weird sort of trapezoidal shaped structures. They'll be stained kind of funky in our real life examples, but that is your phloem. Remember, sugars are phloem on down, okay? And so if you're tapping a tree for maple sap, that's where you want to hit, that phloem vascular tissue right there, okay? So let's move on. Here's a real life example of it, a little tiny woody stem from a plant called Tilia. You can see there's an annual ring, there's an annual ring, so it must be 2 years old. And these little pink things, that's our phloem, okay? So let's take a real life look at that. All right, yeehaw, here we go. Let me zoom out a little bit. So on my little Tilia stem, again, what a cool, very visually appealing image that is, if I do say so myself. Let's go ahead and snap a picture of it. It's just so darn pretty, okay? And so when we're looking at this, we have our pith way down here in the center where the plant is storing a little bit of starch. Here is our xylem, nice big open pores. And we don't see any annual rings, so my Tilia must have only been 1 year. Sad day. Died too young. Anyways, way out here, these funky little purple trapezoids, that's our phloem. So that's where the good stuff is, the sugar and whatnot. Fun fact, birch trees are also full of a sap that is high in sugar content and occasionally tapped, just like maple trees. Apparently it's not quite as rich as maple trees. And some cultures are very fond of it and will drink it straight. That's what true and proper birch beer is actually made of. It can also be thickened and made into a syrup, just like maple syrup. All right, that is a nice picture perfect dictionary definition image of our phloem for xylem, for our phloem for a woody stem. Let's go ahead and take a picture of that because I like it so much. Man, that is pretty. All right. And I do believe that concludes our stem anatomy video. So let's go ahead and stop this. I will see you all next time.